Directions for 33 through 36, decide if the following represent functions or not, and explain why or why not to receive credit. Okay, for this one, the x's are my inputs and the y are my outputs. I'm looking at all of my x's. Each x is different. It all is pointing to the same output, but that is okay. If you were to draw it, -2, 7, 2, 7, 5, 7, and 8, 7, notice those points would pass the vertical line test. So this is going to be yes, every input has one output. If you were to graph it, you could say that the the points pass the vertical line test, but the biggest thing, this is like McDonald's, that there's a dollar menu. This just happens to be there's a $7 menu. Okay, y equals 5x squared. If you look at my charts at the back of the room, you will notice that this is a member of the quadratic family. So this was going to be a yes. I'm just going to say y equals 5x squared is a member of the quadratic family. It's not the exponential family because the squared makes it quadratic. Okay, and then 35, since I'm given a graph, I'm going to try the vertical line test, and I notice right away that this vertical line touches in 4 places, which means that every input has 4 outputs. So this is going to be no, and I'm going to say one input has many outputs, and it's only allowed to have 1. All right, number 36. Every time you put a can into the can return machine, you receive 10 cents. You want to find out how much money you will receive after putting a certain number of cans in the return machine. So I'm going to make myself a little chart. So number of cans and money. Okay, if I don't put any cans in, I won't get any money. If I put in 1 can, I'll get 10 cents. If I put in 2 cans, I'll put 20 cents. If I put in 3 cans, I'll put in 30 cents. And then I'd be asking myself the question, if I wrote down 2 again, how many would I get back? It was still 20 cents, so I'm not ever going to put a different value here. So this is going to be yes, and it's just going to be because every input has 1 output. Right, number 37, draw a graph plotting time versus depth of water to model the description below. The plug is put in the bath, the tap is turned on, then off. Hugo gets in, Hugo's larger brother Tom gets in, Hugo and Tom play with their toys, Hugo gets out, the plug is pulled out, but Tom keeps playing. So we need a graph that says time versus depth. So I'm going to have time this way, and then depth of the water. Okay, so the plug is put in the bath, so I'm assuming that it starts with no water in it. The tap is turned on, which means we're going to fill probably at a pretty constant rate, and then it's turned off. Well, if I turn the tap off, the water level is going to stay constant for a little bit. Okay, but then when Hugo gets in, if you can think about when someone gets into the tub, that makes the water level go up a little bit. And then Hugo's larger brother, Tom, gets in, that's going to make the water level go up even more. And then Hugo and Tom play with their toys, so I'm assuming at this point in time the water's staying at a pretty constant level. However, there might be some little splashing, so water might be going in and out a little bit. Then Hugo gets out, which is going to make the water level go down a little bit. And then the plug is out, but Tom keeps playing. So I'm assuming that it's going to just kind of do a gradual till there's no more water in the tub. All right, last one. Let f of x equals 3/4 x minus 2. Find f of 8. Okay, biggest thing and mistake that I saw people making on this, you do not put the 8 in for f of x. F of x is just letting you know that it's a function. We're going to put, this goes in place of the x, so we're going to go over here and put it in for the x. So we're going to do 3/4 times 8 minus 2. So 3/4 times 8 is 6, minus 2 is 4. Your answer should be 4 on that one.